Good evening. My name is Gyanta Kalisfaradi, and today I will be accompanied by my two friends, Amiro and Faiz Habib. And today we will be explaining about the group assignment video for SEEE 4443, Power System Analysis, where we would do simulation on the Powerwall software for load flow analysis. So first of all, in here, we see a schematic diagram that we have made in the Powerwall software. And this is exactly the same like the one that is given in the assignment. So we have recreated it here again. So in this diagram, we have two generators, two transformers, 7 buses, and 5 transmission lines. And this time in bus 1, it will be the slack bus, and in bus 7 is the regulated bus. So first of all, if you want to check or edit on the generators, you just click on the G1, for example, here. So here it displays the generator option. So you just click on the power and voltage control, and you can see here that the M watt is already set to 100, which is the same given in the assignment. And also, if you want to check the other parameters, you just click on the fault parameters, and they will give you the value for the other parameters. And the same thing with generator 2. You just do the same. You click, you press on power and voltage control, and you see here it's 180. And for the minimum and maximum MVAR is negative 87 and 87. Why is it 180? It's because we are making it the same with the assignment. And also you can check on the fault parameters here, the same like in generator 1. So continuing, we'll see and check for the transformer. For transformer, you click on this part and then it will show branch option. And you see here the limit is 100. And you see here all the parameters are given as well. And for further information, we can check on the fault info, like so. So that's basically it for the transformer. And it's the same thing with transformer 2. But you can see here, the limit for transformer 2 is 200. And we have the parameters here in 0.05 because we have it on the other one is 100, so it's half of it. And this should not affect the calculation because what we are doing now is a load flow analysis, but it will affect the value if we are doing fault analysis. So for now, we are changing it 100 and 200. It shouldn't affect any value at the calculation. Okay, and next, if you want to check the transmission line, you click on the blue line here, just like so. So it will show again branch option, and we have here the limit is 400, just like given in the question. And then we can see the series resistance, the reactance, the shunt, everything just the same like the transformer. And for further information, we have the fault info here as well. So that's basically it for the schematic diagram for the first part. This is on edit mode. If you want to run the diagram, you change it to run mode, just like so. So it's pretty straightforward. And for for the table and values, you press on case information and press the model explorer, and it will show this. It will show all the values from all buses. We have branches input, branches state, and buses. So every value is already calculated and data here in the table in Model Explorer. So that's basically it for my first part. And lastly, all the network here is set to flat start at 1.0. So that's all from me, and I'll be handing it over to my friend Faiz. Thank you.
Okay, thank you, Gian. Good evening. My name is Faiz, and I'm going to show how to run the simulations. Okay, first we need to go to the run mode. We press tools, and then we choose this column. And next we can see the tabs over here, and we can choose either the Newton or the Gauss Seidel power flow, which is either one. So I'm going to choose the Newton one. And as you can see, these are the values that shows over here. Okay, I'm going to run this. Okay. It shows the values for T1 and T2 almost overloaded, and the values for the G1 is 70.49 megawatt and 43.40 megavar. Okay, next. We can see over here the power flows over here. The green one is the power flow for real power, and the blue one is the flow for reactive power. And you can see over here for bus 1, the value of the bus 1 is 1 pu, but the other value for the buses is beyond 0, beyond 1, sorry. And then we can see the real power flow starting from bus 4 to bus 3. And for the reactive power, it's the opposite way. Next, if you want to see the current losses, we stop this simulation first, and then we go to edit mode, draw, and we choose this field box and go to transmission line field. Okay, let's say I want to see the power losses in line 2. We click over here, and it shows the box, and I put the 2 decimals and choose the MW losses over here and press OK. And we get these values for our power losses on line 2. And next we do the same things for L3. We want to check the current losses. We do the same thing. We choose field and then transmission line field. We press over here, and then we choose the AMP flow and press OK. And this is our current losses on line 3. And lastly, if you want to see our power voltages and everything, we go to case informations. We choose this model explorer, and it shows the power and losses gathered in one table. And next, if you want to see the voltages, we choose this buses box, and we can see the voltages data in one tables. Okay, that's all from me. Now, Amiro, the time is yours. Thank you.
Thank you, Faiz. My name is Amiro. So for case 2, we have to improve the voltage on bus 4, which is 200 to 11.06 by 5% to 221.58, which is around 221.6 kilovolts. There are a few methods in which we can implement. One is that the transformer tap ratio can be adjusted. But in our case, we are doing the capacitive power compensation, which is to install a shunt capacitor at bus 4, which will provide the reactive power to the system. And to do that, we go to network, switch shunt, and we click on bus 4. So we usually do trial and error. So after trying so many values, we finally came to the nominal value of 44.5 mega VAR. So we just input 44.5, and after that we click OK. So we need to adjust the format of the capacitor. For that, we click on Format, Display, and Write. Okay, can be seen. So after that, a second. After that, we run the circuit. So now we can run the simulation to see if KV has improved to 221.59 kilovolts. As can be seen, it does improve to by 5%. Also, transformer 1 value has been rectified and reduced to 83%, and even the transformer 2 has been reduced to 94%, and all the buses are above 0.95 PU. So overall, the loading on the system has been reduced, and the reactive generator by generator 1 has also reduced since the capacitor is providing the reactive power at bus 4. Therefore, this is an effective method to rectify the KV in the respective bus. Not only that, all the buses are also improved by 0.95 PU. So as can be seen, all the buses are zero point 0.5 above. And to show the results on the table, we click on case information and we click on model explorer. So we can see, we click on branch state. We can all see the power flow changes right here. And in order to see the bus voltages, we click on here, bus voltages, click on buses, okay? As can be seen, there is an improvement that can be seen here in the PU value. The PU values that can be seen, all of them are from 0.95 above, which means that our calculations and our assumptions were correct. So this is all for our group. Thank you so much.